So nice to see everybody here. My name is Becca Brendel, and I'm the director of the Center for Bioethics, which is sponsoring the gay lecture today. I'll tell you a little bit more about that. One of the things that we do, and we've been doing it through the gay lecture for 101 years, is to bring together a bioethics community. And so we encourage you to learn more about the center if you don't already know. We have students and fellows and alums and members of our broader community here today, and it's wonderful to see everyone. This is our biggest event of the year, the George W. Gay Lecture. It is, in fact, the oldest endowed lecture at Harvard Medical School and the oldest endowed ethics lecture in the country. And we are thrilled today to have Steve Hyman as our speaker, talking about the ethical conundrum of self-control. Let me tell you a little bit about Dr. Hyman for those of you who don't know him. He is a core institute member of the Broad Institute of MIT and Harvard, director of the Stanley Center for Psychiatric Research. He is also Harvard University Distinguished Service Professor and Harold McPike Professor of Stem Cell and Regenerative Biology. From 2001 to 2011, Dr. Hyman served as provost of Harvard University, where he had a special focus on developing and supporting collaborative, interdisciplinary, and cross-institutional efforts in the sciences, arts, and humanities. Before that, he served as director of the United States National Institute of Mental Health, where he invested in effectiveness trials to inform practice. He has served as editor of the Annual Review of Neuroscience, founding president of the International Neuroethics Society, president of the Society for Neuroscience, and president of the American College of Neuropsychopharmacology. He is a fellow of the American Academy of Arts and Sciences, a fellow of the American Association for the Advancement of Science, a distinguished life fellow of the American Psychiatric Association, and a member of the National Academy of Medicine. At the National Academies of Sciences, Engineering, and Medicine, he has served on the council, on the governing board of the National Research Council, and chaired the National Academy's Forum on Neuroscience and Nervous Systems Disorders, which brings together industry, government, foundations, patients groups, and academia. He is currently a member of the Committee on Science, Technology, and the Law. He chairs the boards of directors of the Charles A. Dana Foundation in New York and the Wyss Center for Bio and Neuroengineering in Switzerland. And he's also director of Annual Reviews, a nonprofit science publisher. He also holds a number of roles in the private sector, where he is a director of Voyager Therapeutics, Cyclerion Therapeutics, and Vesalius Therapeutics. He serves on the scientific advisory boards of Janssen Research and Development and F Prime Capital. He started this journey with his bachelor's degree, summa cum laude, from Yale, an MA from the University of Cambridge, which he attended as a Mellon Fellow studying history and philosophy of science, and an MD cum laude from Harvard Medical School. Please join me in welcoming Dr. Hyman for his George Gay Lecture in Medical Ethics on the ethical conundrum of self-control. Welcome, Dr. Hyman.
So it is really an honor. I mean, I am really very, very delighted to be here and to give this lecture and to give it to this audience. I know many of you, and I especially want to thank you, Bob Trug, for inviting me. You and I go way back to your taking on university-wide roles when I was provost, and I really appreciate the excellence you brought to positions that, if anybody knows how Harvard works, are always fraught, right? So you did a great job, and it's great here to be with old friends. Now, this is a bit of an experimental lecture. I did very much wanted to talk about neuroethics, because there's a growing interest in neuroethics, which is a first cousin of bioethics. and people applying for grants, but it's really a frontier. And I think it's been made possible by progress in the neurosciences. But as you'll hear, I'm going to talk about some neuroscientific models, but the science is far from complete. And I think that maybe in the end, when we think about how neuroscience bears on our ability to control our intentions and our behavior, maybe the most important ethical lesson will be the need for epistemic humility. I mean, we in the medical community often act as if we know why people are doing things. We blame them, we do this and we do that. And I think, if anything, if we can begin to deconstruct some of this certainty and approach, whether it's public health or individual patients, with greater humility, that will be a really important victory. Too often, as we think we know more, of course, we gain more, we think we have more certainty, and that is absolutely not the case for this. Okay, so neuroethics has broad areas of concern that extend beyond the traditional remit of classical bioethics, but many people are involved in both at the same time. So the ethical implications, so the things I'm going to focus on are in the blue italic. So modern neuroscience problematizes, yeah, that's right. Modern neuroscience problematizes the human experience of selfhood, of being a self, something we take for granted. And when I've given earlier versions, let's call them prodromal versions of this lecture, not long ago at the University of Oxford, people couldn't tolerate it because I was violating their intuitive sense of who they were, but we'll try it here. It problematizes the experience of selfhood, of personal identity, of decision-making, of agency, and of moral agency. And of course, that is going to reflect on the more classical bioethical issue of self-control and health behaviors. Another topic which I won't touch on, but I just came from a conference in Washington on, is neurotechnology. And combined with AI, invasive neurotechnologies are getting better at terrifying things like mind reading. Now, right now, to have your mind read, you have to agree to be in an MRI for 2 hours. It's, so they're not going to sneak up on you, but it is nonetheless terrifying. But also writing into brains, and increasingly for psychiatric and behavioral disorders, not only for movement disorders. And that's a very rich topic. But in addition to the ethical implications of advances in neuroscience, this is a topic that also looks at ethics itself. There is a neuroscience of moral reasoning and ethics. And in clear distinction to what most of us learned in beginning philosophy and ethics, where people were thinking, John Locke was thinking about natural law, and David Hume was thumbing his nose at him historically. But when you study the nervous system, you begin to realize that moral principles are contingent products of human brains, which are themselves contingent products of evolution and chance. And also they are not universal among humanity. The structure and function of human brains, of course, shapes and constrains our ethical principles. As human beings, we have a lot in common with each other, but individual sets of moral principles and ethical beliefs are shaped in the context of local history and culture, and very profoundly so. But the other thing that, if we take neuroscience seriously, and the ethical implications of this are enormous, human brains are tuned for fitness, for evolutionary fitness, not for truth. We do not have access to the truth. And with that, let me outline the talk very quickly. Automatic, unconsciously formulated intuitions about ourselves and others are broadly captured by what's often called folk psychology. This is not a pejorative term. It just really describes this natural understanding. Neuroscience deconstructs this intuitively comfortable mode of sense-making and replaces it with mechanisms that are absolutely opaque to introspection. And again, this is something that doesn't go over very easily. But our consciousness is a great input device. Consciousness is not an epiphenomenon to a neuroscientist. It's how we take in a lot of information. It's a capacity-limited serial processor. It's how we deliberate. But we have no insight when we introspect into how our minds are working. I mean, I can tell you a story about why I went into medical school, but that's a story. I can't see those neural circuits. And when I lift this, I just lift it. I have no insight into the commands that fired certain opposing muscle groups for the right number of milliseconds and stabilized my shoulder. And all of this is just happening in the background. And I have no way of accessing it without special technology and equipment. So neuroscience deconstructs these things. Now, we have to think about how we can use this to reflect on what we do as medical professionals and public health leaders, because we as a group often apply not emerging scientific understandings, and again, I make no claims for anything near completeness, to issues of health behaviors. Instead, we use folk psychology, which is so familiar to us. And we tend to overestimate the control and willpower that other people have because we overestimate what we can do. We'll come back to that. And then I'm going to illustrate some of these things all too briefly from addiction, from eating behaviors, both anorexia and obesity, and from mental disorders, and especially ADHD, which is a disorder of behavioral control. Now, while greater attention to neural mechanisms of behavior will, I think, if we do it right, increasing our humility, advance medical practice, it's also true that we had better not think our way out of folk psychology, because conversations that we have with anybody, including our patients, right, has got to be addressed at this very human level. And the problem, the trick is that these two views are completely incompatible. You can't integrate them. At least I would argue you can't integrate them. So we're always sort of shifting, like in an optical illusion, bunny duck, between our scientific understandings and folk psychology, with which we absolutely have to communicate with each other. You know, you don't want to say, honey, your hippocampus is really beautiful tonight. Okay. Folk psychology, as I said, is not a pejorative term. It denotes our intuitively familiar ways of making sense in mentalistic terms of our actions and those of others. Human beings have an ineluctable experience. You cannot think yourself out of this. Even neuroscientists can't think themselves out of the experience of being a self that has subjective experiences, memories that feel truthful, hint, memories are not truthful, intentions and agency, and the ability to make decisions freely and act upon them. We subjectively experience being a mind, but having a body, right? I mean, you feel like you are your mind, but you have a body. And then we criticize people for Cartesian thinking, separating mind and body, but of course that's what's natural. That's how we experience ourselves. And so to correct erroneous Cartesian intuitions is not automatic. It takes effortful cognition, and that comes up again and again in this topic. Mentalizing is automatic. Like all higher primates, certainly like all of our close cousins, the great apes, humans live in social groups. Thus, our fitness depends on the ability to adaptively regulate our behavior with regard to the intentions and behaviors of others. And we have to mind read, right? Otherwise, we won't get who's hostile, who's offering, candy, and so forth. Social cognition, the specializations of our minds to process social information, is based on automatic neural computations that are highly specialized. In fact, there are theories, disputed, but there are theories that the enormous growth of the human brain compared to our primate ancestors had a lot to do with negotiating complex social hierarchies and social situations. And as we evolved, sort of an arms race for better social cognition. People, in terms of social cognition, humans are very varied, right? We have people who don't relate very well, we have people who relate well, and we have psychopaths, some of whom are quite successful, right? These are all different human aspects of social cognition. Interpreting social signals, again, rapid and automatic, smiles, frowns, bodily posture, we don't even think about it, right? It's just, right, you automatically sort of respond, you know what to do, and we have developed as young children, except in autistic individuals, this habit of mentalizing. It's sometimes called theory of mind, you know, by, say, Uta Frith and other British theorists, but it's really mental. That is, attributing both to ourselves and to others automatically that they have minds with beliefs and motives and intentions. Now, the ability to mentalize is impaired in autistic individuals, and it can constitute both a distressing and impairing feature of this variation on human cognition. And we'll come back to that fact right now. So this is just, so these brain pictures are not anything but an illustration. But you know, this is based on imaging. This is a review article, and basically, it may even replicate someday. But the important thing here is that we have something called the default mode network. We have the default mode network, which is a part of the brain which is active. It's called the default mode because when we're just daydreaming. But it is especially active when we're thinking about ourselves as minds and others as minds. And it is this part of the front of the brain called the ventral medial prefrontal cortex, which is particularly active when we mentalize. And in healthy people, there are slightly overlapping regions in these MRI studies when we think about other people's minds and we think about ourselves. Whereas it is, from these studies, it is said that people with autism don't really use this second overlapping region when they think about other minds. They rely on the same region for self. Now, whether this is, again, a lot of this MRI research, again, I think I've talked about humility. We should, as a field, we should be not believe we quite know the truth yet. But the reason that I am showing you this is because our brains, when I say they evolved for fitness and not truth, this is an example of brains having evolved for fitness, right? For mentalizing, surviving in social situations. And it means that people with autism as characteristic can be at some disadvantage in these kinds of social situations, right? And I will come back again to this distinction between fitness and truth in a second, but one of the things about autism, and also true of people with schizophrenia, is that reproductive fitness is actually diminished by virtue of having a social impairment during the age at which people tend to form families, right? And so it's been studied in several countries that people with autism or people with schizophrenia have about a quarter as many offspring, as many children as their unaffected siblings. That's a pretty good control, and this has been replicated in 3 Scandinavian countries. And so behavior really has an enormous amount to do with this issue of fitness. So coming back to this idea about fitness versus truth, the way I put it is that evolution has played a trick on us. Forgive me if anyone takes umbrage at my personifying evolution or sounding teleological, but it really it does capture this trick. brain circuitry that underlies our ability to mentalize, and here's another picture of the default mode network, and here's the ventromedial prefrontal cortex, and this is part of the posterior parietal lobe. Brain circuitry that underlies our ability to mentalize, that is to attribute minds, motives, intentions to others, and thus to respond adaptively, is absolutely critical for survival. And I've already given you an example, even of decreased reproductive fitness if you have a social impairment during your teen years and young adulthood. This circuitry is very much conserved in evolution. We see it in primates. It also taps very much into threat circuitry, specialized circuits based in the amygdala that allow adaptive responses to danger or to threats, and to reward circuitry. Social interactions are highly rewarding in the right circumstances. Variation in this circuitry, again, that is highly genetically influenced. For polygenic forms of autism, the heritability, not to fetishize heritability, is in the 0.8 or 0.9 region. And these genetic differences, we believe, alters this circuitry, and but it's simply, I guess the question is, if there's reduced fitness, why do these genes continue? And the reason is because what gets passed along are either genes of such small effect that they only give you this trait when they come together in large number, and so they're underneath the selection radar, or else new mutations in the offspring that are not in the parents, so-called de novo mutations that have never been through the ringer of natural selection. So this idea of the way our brains are structured for social cognition has a lot of evidence for a central role in fitness. Now, overall, one might imagine that these evolutionarily conserved, highly developed circuits and their computations and the cognition that results would give us an accurate picture of reality. But they don't. What they do is they support folk psychology. Now here, so this is really, I'm not denigrating folk psychology. This is what our brains have been optimized for. It's just that evolution was not interested in us being scientists, right? Evolution was interested in reproductive fitness and flourishing and so forth. And therefore, the structure and function of our brains, our sense of being a self with a mind, is not epiphenomenal, but actually exactly what our brains evolved to do. What are the implications of just starting to think about this for law, education, and medicine? Well, folk psychology explicitly undergirds much moral reasoning, right? And much educational, maybe all of educational and legal practice. I used to have debates with a law professor from the University of Pennsylvania who was, always arguing that neuroscience should stay out of the courts, and that we can only operate at the level of folk psychology. Whether that is always just is another question. But what he pointed out was that guilt in criminal justice depends on a psychological level analysis that the defendant was rational at the time, that the defendant understood what he or she was doing and had criminal intent. Having an MRI picture showing some abnormality, some tumor in the brain, doesn't necessarily demonstrate causality with respect to altered capacities for rationality, for knowing right from wrong. I mean, sometimes one can get that evidence, but it's not so easy. And so the argument is, for most legal scholars, is really to preserve folk psychological level analyses as far as possible. Now, the problem with this is, for me as a scientist, is there are miscarriages of justice because looking at especially invisible mental diseases is very far from people's minds. You know, in the papers in the last few days, there's a description of another case of what may be postpartum psychosis of a mother that strangled her children, and because she looked it up on the web, how to kill your children, that was proof, right, of intentionality and cold-blooded planning, hardly, right? And so while I respect, this is not a law, some of you are, but you know, this is not a legal audience. So while I respect the need that for juries to think in terms of familiar mentalizing and folk psychology, and to describe criminal intent at the explanatory level that people are comfortable with, I also think that there's so much exclusion of neuroscience, clinical examination, with the prejudice against, almost against letting the guilty go free instead of finding the innocent guilty sometimes, that it deserves more debate and thought. But that can't be the goal for this talk, because this is a medical and public health audience. But folk psychology also underwrites many practices in medicine. So as human beings, physicians and other caregivers automatically and intuitively attribute to others free choice and the ability to control their behavior. And we also tend to overestimate these aspects of other people when we're, not all of us, right? Not everyone, but often when we're addressing addicted people, right, and their fate. Or when, you know, we're talking to typically a young woman with anorexia nervosa who has a distorted body image that defies credulity, right? I'm so fat and she weighs nothing. Or obesity. It's interesting with GLP-1s. I've heard a lot of people say, so it's biological after all. Well, everything is biological, right? It's what were you thinking before, right? Or the ability to study, work, and conform in people with untreated ADHD. So to reconsider such attributions in the still incomplete context of neuroscience, of scientific evidence, requires, again, at this stage of our knowledge, discursive, effortful cognition. You know, how do I think about this addicted person? What really is the evidence for what is controlling this person's behavior? What do I know about it? Okay, so now let's go deeper into the brain. And this idea of the brain as a prediction machine actually dates from the 19th century, from Helmholtz. And some AI scholars call their artificial minds Helmholtz machines. But it's really been in the last 15 years that people have started to think about brains in this way. And you'll see why it's germane in a second. Right now, it may not seem germane. So we all, again, when you start philosophy and you read about the British empiricists, you have an idea that sensory perception is bottom-up, stimulus-driven, and gives you an internal representation of the world. So there's this tree out in reality, and I see it, and there it is, first on my retina, and then somewhere in my brain. Here at Harvard Medical School, beginning in the late 1950s, David Hubel and Torsten Wiesel, who won a Nobel Prize for this, developed a more sophisticated model. They realized that there wasn't your visual cortex wasn't a photographic plate, but rather when you see something, here a butterfly, the retina projects to the thalamus and to the primary visual cortex, and your brain is already deconstructing the sensory inputs into different components. Shapes get decomposed into edges, and then there's concern with movement and with color and where something is in space. And then later, so here this spaghetti is the visual circuit of a human drawn by David Van Essen. I apologize for the oversimplification, but it gets integrated with the tactile world, right, and the auditory world, and you develop a picture of the world, but it's still bottom up, outside in. But then who does, see, now we're coming back to the self again. So who sees this? Who saw that butterfly? Does it feel like your mind is like a homunculus or homuncula sitting and watching television on the outside and quickly responding? So, you know, you don't want to crash into this tree, so you pull some levers and alter your motor behavior. I mean, that's really, I mean, we know better, right? But intuitively, it can feel that way. We'll skip Descartes here. We talked about him already. But actually, neurons in the brain are not watching complete scenes and making guilty verdicts and so forth. Neurons in the brain, it's dark in there in the skull, right? They have no direct access to the world. All they know about are some chemical and electrical signals from the neurons that they synapse with. And it's often a lot of them. They can synapse with 1,000 neurons or more. But that's all they know. And, you know, when you're sitting here, right, you're filtering, right? You're not thinking, maybe now you will, but you're not thinking about the weight of your clothing on your skin, right? And you're not thinking about the noises that the HVAC is making, right? This is what attention is doing. It's filtering out a lot of distractions. Now, during the day, it's not just silly things like the weight of the clothes on your skin. You have a lot of conversations. You attend to some small fraction of what's said. And then you'll remember a tiny fraction of that. You're making a selection. The world is just too complicated. It's too noisy. When I turn my head, what do you think happened? Do you think I had a complete picture with Ed Hundred and Matt Baum, and then I turned over here and have a complete picture now inscribed of other people? No. I mean, we would crash into the tree. I mean, it's just too much information, too much bandwidth, right? And so, but the problem that the brain has to solve, given what it gets from the world, is it's not making accurate representations that turn over, it's making inferences about what are the causes of the sensory inputs that I'm getting. What is it out in the world that's doing that? Now, on the one hand, this is not novel. I mean, Plato had his cave with shadow play, and Kant had his noumena and phenomena, but this is actually different because Plato and Kant still were thinking bottom up. What has come to be clear is that that perception is not bottom up. It's actually an inference driven by internal models. And the audience for this, for sensory perception, is not a self. It's not, you know, it's not this homunculus sitting watching television, but it's just more neurons downstream, right? And ultimately, it's the motor system, which is the great test of whether we got it right perceptually, right? That's really how we learn, right? Is motor system another audience of neuroendocrine neurons, but that's another topic. So how does it work? So the idea is that the brain uses past experiences and general knowledge to model the causes of these sensory inputs. As I said, the brain doesn't paint successive representations. There's just not enough bandwidth to do that. Instead, think of it as a software compression program. As we move our gaze, what I learned, and I've been in this room already, my brain is very good at sort of figuring out where we are. We all do that naturally. The sensory inputs are served when they are mismatches between expectation, between the model my brain has of what I'm going to see in this room and what's coming in. they are rapidly acting error correction signals, right? And they update this model extremely quickly. And then again, this gets tested by motor behavior. So it looks something like this. And here's an interesting discovery. If you look at the number of fibers that are descending from higher centers to sensory inputs, the top-down fiber tracts have much more density, more neurons than the incoming fiber tracts. So again, you bring a model to the world, and so you have this model, and then sensory inputs as they go higher in this hierarchy of neurons, you have error corrections for this prediction, and then for this prediction, and for this prediction, and you update this mental model. And there is evidence from physiology for this, but I think more interesting are some of the things like optical illusions. So knowing, my telling you, but knowing that these two lines are exactly the same length doesn't help you see that. It doesn't cure the illusion. This one looks longer than that one. And we could cover the arrows and see what's happened. And the reason this happens in many kinds of illusions, but not just parlor tricks, but when we misjudge things that are not really there, is because, again, the brain knows that the world and sensory inputs are noisy and uncertain. So it not only uses sensory inputs for error correction of its models, but it also has models of the reliability or the precision of the sensory inputs. And it has certain rules that, by the way, great artists understand about the positioning of light and shade and what they do to the way we see an object. If you look at a pointillist or an impressionist painting and you look at the brush strokes up close, it doesn't represent anything except the brush strokes themselves, but you back up and pictures of people and, if you're Monet, water lilies appear and so forth. And empirically, artists have worked out these rules, but we obviously have strong inferences about what arrows pointing out versus pointing in might predict for what we are seeing. So we make this correction. And some of these are rigid. We exploit this. Movies, motion pictures, exploit the brain's desire to connect images that are flickering by at a certain speed into a single moving film. Okay, so again, perception and memory serve fitness, but not truth. Perception isn't an accurate representation of the world, but it's not an illusion. That's the important thing. Rather, it's a top-down construction that is ultimately tested for its utility and accuracy by action in the world. Our sense of the self as an agent, so that instead of being a homunculus watching TV, is also constructed by the brain. It's the protagonist in lots of scenes that we participate in and imagine. Episodic memory, memory of persons, places, and events, is not a veridical record of one's experience. It's not a video camera. The goal isn't to have a file with every experience that you've ever had accurately filed away. Disk space would be full pretty fast, and you'd be pretty impaired. Rather, our episodic memories are always being automatically updated, compressed, edited, conflated, right? For those of you who were medical students here like me, how many times were you in this room? But I don't have individual memory. I have a few salient individual memories of things that have happened, but it all gets conflated, right? But it's useful. I can find my way around the room, and I know where the irritable old professor used to sit like Polyphemus in his cave or something. Episodic memories, semantic memories, facts, imagining, planning. But why do we even have them? Well, I mean, there's been a theory that's really about that Dan Schachter, a professor of psychology at the college, began to play with, among other people, some decades ago, that it's really about prospecting, right? That they are really sources for future-oriented, counterfactual hypotheses about what the world could be like. What if I do this? What if I do that? Now, they're not, they're not written out to be accurate schemata, right? In fact, they're sort of random in some ways, daydreaming sometimes, but actually they really are about planning for the future. Again, about the brain as a prediction machine. And in this case, quite clearly, the self, yourself, myself, is often the protagonist in these fantasies, right? There I am, right? Planning my future or thinking about what happened to me. And so myself is, again, a construction of neural circuits. There's no one place in the brain where it all comes together, let alone there being homunculus. You can imagine, why are false memories and conspiracy theories things that happen, and why are they held on to so densely? And, we don't really understand this, frankly. We don't understand psychotic delusions fully, but the idea is that maybe the top-down model building, for whatever reasons, maybe in certain powerful social contexts, becomes so strong that they're resistant to bottom-up error correction. But that doesn't say anything, right? That's just a description. I think it's really, but at least as a framework for empirical investigation. Now, I don't think I can knock on the door of people with conspiracy theories and say, I would love some of your DNA, and could I put your head in an MRI? But at least there is a bit of a framework to think about these things. Now, I've been talking about very neutral things like turning my head and rapid error correction, and the need for things really to work instantaneously. So again, so I don't crash into things, fall off a cliff, run into Professor Polyphemus. But our emotions work in the same way, or things with emotional valence. So this is just a picture of somebody in this magnet looking at a fear face. Darwin was the first scholar to be really interested in how expressions of fear and anger or happiness were served as universal communication tools. And we still use these emotional faces to test emotion processing in people's brains. So somebody looks at a fear face, and then I mentioned that there's this part of the brain, the amygdala, that gets activated, that is the center of a lot of threat response. It talks to other parts of the brain, it gets your fight or flight response going, and so on and so on. And in the magnet, people actually can look at, what communicates this information, just people's eyes, and the speed at which there is amygdala activation. And people have done experiments where they've shown a fear face or an angry face for just 33 milliseconds, and then they've masked it, and the person is not even conscious of it, and the amygdala is still activated. So part of this brain as a prediction machine, again, is about fitness. It's about not running into somebody who's going to hurt you, right? Avoiding somebody who's going to hurt you. But this is the origin of our implicit biases, right? Now, the implicit biases, the content of these biases come from the culture and from your history, right? The brain doesn't start out with prejudices, right? The brain just starts out with this equipment aimed at fitness. And then the culture starts to teach you in ways that are not conscious, right? You imbibe from this culture a set of beliefs. And decision-making then becomes aligned with a lot of these implicit biases that are often automatic and effortless. And suppressing them. Now, let's say you have an implicit bias about strangers of a different race. That doesn't make you a racist, right? That just means you have a brain that is a prediction machine. What's important, though, is that you can correct those by conscious, deliberative thinking. It takes effort, whereas the initial implicit bias is effortless and automatic. And most people actually accomplish this, but this is really I think an ethical outgrowth of this idea of the brain as a prediction machine. When we do have harmful implicit biases that interfere with who we hire or who we ask to co-author papers with us or whatever, the idea that a single training or two trainings will reverse this is insane. I mean, these are deeply ingrained mechanisms in human beings, and these cultural exposures that may drive very unfortunate, prejudicial sets of biased contents have been experienced for a lifetime. So it tells us that if we're really serious, we're probably not going to reform people one by one. We have to create situations in which those biases get neutralized, frankly, because I don't think we can, in any sensible, cost-effective, at-scale way, cure people of these implicit biases. We should teach them about it. They should know they exist. They should know that we're not saying that they're a bad person, right? But we have to find other ways to deal with these. And I think these models really, I think, make that point very, very strongly. Now, some people say, well, if the brain is doing all of this, then, things like consciousness, and if you say the self doesn't exist, then it's a quote epiphenomenon, it doesn't matter. And I think I've already made the point that it matters a great deal. That's what the brain, the fitness of the brain evolved so that we have, the experience of having a self and mentalizing with respect to others is a part of our, the cognition that allows us to survive, just as, activating threat circuitry at the drop of a hat. Joseph Ledoux, who first really focused on the amygdala, said it's better to mistake a stick for a snake than a snake for a stick. And I think that really is the issue. But if you don't mentalize others, which again is scientifically false because it's assuming that they have a self and it's doing all of these things, if you inquire about it, is actually very important, because people who can't do that, as I've already said, have autism, have this impairment, right? This is what evolution has put forward. So we can argue successfully, and we're not doing metaphysics here, that there's no free will. But if you have the experience of external control, Maurizio might hospitalize you, right? Because you might be psychotic, right? And so forth. So again, these are not epiphenomena. We don't want to eliminate these things. We want to understand them. And we have no choice but to experience a folk psychological world. I don't. Even when I'm talking to you about this stuff, I'm experiencing the world as folk psychological. Even though I know it's not veridical, it is not true. And these mechanisms are not available to introspection. Now, one interesting thing, I will show you one iota of neurotechnology. This woman, Jan, has an ALS-like disease, was paralyzed. She got a brain implant, an electrode, actually a 100 electrode array in her motor strip. And she learned what she wanted to do is to be able to feed herself, to feel agency again. And of course, in this version, this is not a public health intervention, right? This is in a very costly lab and so forth. How did she learn to move a robotic arm to feed herself a piece of chocolate? Well, she just imagined what it was, just as if she were feeding herself chocolate. And the electrodes, just read and decoded the activity of the neurons that were active when she was imagining feeding herself chocolate. And over time, maybe it was a little clumsy and she had more imaginings. And lo and behold, you don't need an engineering degree, you just need to be human. right? And these things can get decoded. But if I were to try to introspect, just as I said at the beginning, and understand what circuits I had to activate to feed myself chocolate, let alone control a robotic arm, I'd be pretty clumsy. I think the chocolate would end up in my boot. And so again, these patterns of connectivity, these synaptic networks, are completely opaque to our introspection, right? Even though we believe, right, through folk psychology, that we are a self that is controlling all of these movements. Well, this is not unprecedented in science, right? We have a quantum mechanical world that we cannot intuit or experience, and even physicists tell me they can't intuit it. And then we have our macroscopic world, which makes sense to us. It's very much the same thing. And in quantum mechanics, you have the particle wave. I'm not going to. This is a fun picture, but when you measure what the wave is doing, say through a two-slit experiment, it collapses right into what looks like particles. But the point is that as we have neuroscience and folk psychology, we have quantum mechanics in our macroscopic world, which we really can't integrate in any sensible way. In fact, Einstein spent the last decades of his life trying to come up with a unified field theory, and he didn't succeed, but no one else has either. So this is not, the fact that we have two ways of looking at the world, our intuitive way and a scientific way, is not unprecedented. All right, so addiction. All right, so it's a chronic relapsing disorder characterized by compulsive drug seeking, and there are, pathetic pictures of people who have run out of veins. She's trying to inject maybe into her jugular, and we have now over 100,000 drug overdose deaths in the United States. But we still have this question, again, it's right at the fulcrum between thinking folk psychologically and thinking scientifically. And the question gets asked, well, look, for her to get drugs, she had to find money, and she had to go and find her dealer, and she had to then find a safe place to inject and prepare the heroin, and now probably contaminated tragically with fentanyl, and remember where there might be a vein and round around. So that's a lot of time. It's a skein of voluntary behaviors. So when we say medically that somebody has lost control over drug use, what the heck are we saying, right? How is it possible to lose control over an extended series of voluntary acts needed to obtain and administer drugs? And I think that question makes a lot of sense if you are in a folk psychological model, right, where she should have come to her senses, right, and said, gee, I shouldn't do this, right, this is bad, I'm gonna get treatment. And in this model, family, friends, too many medical professionals, law enforcement, attribute the motives of the addicted person to moral slovenliness, an unwillingness to tough it out. We've all heard these things. So what does science have to say? Now, it really is, the science is really incomplete, but we also haven't convinced enough people that the science matters, right? There's still a lot of people who get punishment when they could benefit from treatment, and there are a lot of people getting treatment who are not getting opiate replacement because if you really were treating somebody, there's the theory they should be clean, you're just replacing one addiction with another. Again, some inference about motives and so forth. Surely this is an ethical issue. Right? How do we bring science into this? So just very quickly, what is science? 2 seconds. What does the science say? The science says that all addictive drugs release the neurotransmitter dopamine. There were experiments with, famous experiments with rodents pressing levers for stimulation in parts of the brain that release dopamine, 1950s in Canada, lots of other experiments. But the point is that drugs that are actually addictive, that is, that create craving and withdrawal and this drug-seeking syndrome, all release dopamine, and they release it in emotion-controlling and motor-controlling areas in the forebrain, like the nucleus accumbens. And dopamine in the brain actually is about survival. It's about fitness. It is coordinating the whole brain to maximize rewards, to maximize food, reproductive opportunities. Otherwise, the budding yeast would have won out. And fresh water when you're thirsty, and safety, and social interactions. And addictive drugs are Trojan horses that tap just directly. They cause direct dopamine release, bypassing all of the homeostatic or reproductive value of experiences that are naturally rewarding. And dopamine so I was talking about sensory inputs as an error correction. That's what dopamine does. It's a learning signal. I'm not sure anybody is really up for this slide. But dopamine neurons normally they're lackadaisically firing, tonic firing, and then if you're recording from the midbrain the dopamine neurons of a macaque, which was done by Wolfram Schultz first, and a little door opens and there's a sweet syrup that the macaque loves and he drinks it, you get dopamine firing. But if you pretend to be Ivan Pavlov and you have a light that predicts the syrup, now the dopamine is released when the light comes on. And if you have a tone that predicts the light, that predicts the syrup, you have dopamine released when you hear the tone. And if the syrup in all of these situations is just as expected, no more, no sweeter, there's no more dopamine when you drink the syrup, right? So the dopamine, and one other thing I'll tell you, if the syrup is not, if you do an extinction experiment, right? You have your light and the door opens and there's no syrup, the dopamine neurons pause. It's a punishment signal. So what does it do? The dopamine comes on as the first reliable predictor of reward. It's correcting an error. I didn't know that tone meant anything before. Now I do, right? I didn't know that the light meant anything before. Now I do, right? And so basically, the brain is developing a new model of how the world works, right? When that light comes on, I have to be prepared. And because of that punishment pause, so for something that's natural, so say you love eating, for whatever reason, a mealy Macintosh apple, and one day there's a worm in it, right? A whole bunch of things happen, but the dopamine neurons pause, right? And you will lose your taste for Macintosh apples, at least for a while, right? But if you take a big drag on a cigarette and you start coughing up your lungs because you have emphysema and lots of other things as a result of smoking, your brain, because nicotine directly causes dopamine release, you're still getting an error correction that says, this is good, let's do it again. And it overrides the actual experience. It's this powerful learning signal, right? Error correction signal. So drugs of abuse have an advantage over all other rewards. And of course, because drug seeking is important, remember I said dopamine coordinates all kinds of reward gaining in the brain. It coordinates drug seeking in a part of the brain called the basal ganglia, where if you're an athlete, this is where or if you're Luke Skywalker, this is where you feel the force. But if you're an athlete, this is where you internalize how you throw a knuckle curve, right? And it becomes totally automatic. In fact, later, if you think about it, you do terribly, right? This becomes totally automatic. And if you are an actor, this is where your lines and your movement on the stage go. And actually, if you flub, what you have to do is not think too much, but get back into the routine, right? So what this is doing is it's automatizing drug seeking, but and this is really important, it doesn't make people into zombies, right? So that if where your dealer should have been, there are these guys, you don't walk up to them and say, I'd like to buy some methamphetamine, please. You come up with another plan. And that kind of flexibility gets misinterpreted, again, as rational control over behavior. It's evidence against people that they planned and intended to misuse drugs, right? As opposed to understanding brain mechanisms, and this kind of flexibility is built into anything, including when you forget your lines when you're on stage, or when you throw a bad pitch and you have to pick yourself up and throw another one. So people don't become zombies. But these models of what dopamine is doing and how drug seeking gets encoded do refute simple attributions of intentionality and moral weakness. And that's because if this person who has become flexible and has not tried to buy methamphetamine from these officers then walks away, that's when people feel this intense craving and have to begin very intensive drug seeking. So these models, the science is imperfect. It's early, but it gives us a view of the addicted person that's very different from a folk psychological or moral model. Addicted people don't choose to pursue pleasure once they're addicted. Rather, their brain is really altered under this pathological dopamine signal in a way that comes to control their behavior. And I'm not going to go through all of this. But the idea that they are morally weak and responsible, of course, leads people to think that punishment is more suitable sometimes than treatment, and to not want to trust people who are addicted, say with opiate replacements like buprenorphine, which empirically leads to much worse outcomes and more deaths. So how do we as medical educators advance views of addiction based on this still incomplete science? And how do we compete with intuitive folk psychological attributions? And I think we have to think seriously about that. And I think it is an ethical matter, right? This has to do with how we treat people and whether they get better and whether they survive. And just going into the lab and knowing doesn't translate, especially in fraught situations like this, into altered policy and better outcomes. So one slide on eating behaviors. You know, again, the brain having predictive models makes a certain amount of sense when you look at anorexia nervosa, which has perhaps the highest lethality of any psychiatric illness, maybe 20% lethality over the life course. But somebody who is very thin looks in the mirror and sees somebody who's fat. And what do normal people do living in the folk psychological world? They're not bad people, but they say, God damn it, you're not fat, will you eat? You know, and it just doesn't compute with other people. But this person has a different, there's usually, you know, still 10-to-1 female, although men are slowly catching up, unfortunately for them, has this model of herself, and it's not being corrected by sensory inputs. And maybe that will give us some help in treating it, but again, maybe it will also give us some insight into how to treat people. And I've already talked about GLP-1s and obesity, and the idea that we never should have treated eating, you know, unhealthy eating or obesity as purely a decision made by a morally slovenly self that is out of control. At a minimum, there are genes and nutritional contexts in the world that make this more likely, but even that's way too simple, right? And the fact that these drugs work shouldn't suddenly have changed this the scales fall off people's eyes to say it's biological, right? We have to understand, again, in terms of these, the way the brain works, the complexity of these issues of self-control. And ADHD is, again, is a condition, and I chose it because maybe it's a little better now, but back when I was NIMH director and afterwards, there was opposition to the existence of the diagnosis. People would say this is just teachers who don't want to teach, parents who don't want to parent, kids who want to take stimulant drugs. Actually, the kids don't like the drugs because it slows you down. And again, why the opposition to this diagnosis, despite, I guess I might show you, all phenotypes, most behavioral phenotypes are genetic. That doesn't make it a disease, but it does cohere, right? It's a thing, right, in nature to some degree. There's research showing that the cerebral cortex in these children is maturing more slowly than here's ADHD cortical thickness versus typically developing. The prefrontal cortex is most affected, which has to do with behavioral control. But there remains, again, because of the power of folk psychological attributions of, mentalizing and control, and if I can control myself, you should be able to control yourself, right? There is opposition to these kinds of diagnoses and to treatment. And why is there always medication shortage? Because the DEA beats everybody else because they kind of doubt that this is real, and they know that stimulants are abusable. So again, what does the medical community have to do? Now, of course, all drugs have side effects. All drugs have downsides. These drugs are potentially abusable in the wrong hands. We acknowledge all of those things. But again, there are these enormous public health problems and individual medical problems driven by these attributions of moral weakness, right? You just don't control yourself. All right, so to end, we know that human behavior profoundly influences disease risk, disease progression, adherence to treatment, and so forth, and is a great concern to medicine and public health. But we're all human, and so we automatically attribute to people, freer choices and greater control than they are actually truly likely to have. And these models influence clinical decision making. I know no one in this room would do it, but how many people have said, well, your LDL cholesterol is through the roof, but let's try diet and exercise first, right? And then somebody comes back in 2 years and nothing is, or don't come back because they're ashamed they haven't exercised, right? What is good about that, right? Why is this idea that effort and character building are better than for a physician to emphasize over making somebody healthy or staving off a potentially dangerous disease? And I think, again, in medical education, we really do not think about these things, right? We let everybody leave medical school or nursing school or whatever with their own mental models of what makes people tick and their own prejudices about, whether effortful, likely failed attempts at health behaviors somehow have superiority to, again, when the data is there, safe and effective medicine. Now, they're not always there, right? And, ethically, as we are teaching young developing professionals, whether physicians or nurses or people in public health, we have to confess there are many scientific unknowns about the control of behavior. I've given you some models about the brain, which I think are kind of trite-ish, that really tell us that this idea of a self with, free will that can control behavior is a reality in our heads and therefore in everybody else's heads. I think much better, other than overclaiming for science that is not ready yet, and just to end where I began, is to emphasize epistemic humility, right? Before you tell somebody to do X, which never seems to work, right? That has to do with self-control, you know, my family can tell you we have a freezer full of ice cream and I can never swear it off, right? But we have to have humility about what we really know about this. And where we have safe and effective treatments, we should really weigh the evidence and not our own personal prejudices based on folk psychology. And also, I think it's time in health education and medical education to begin to think about how the brain works, right, and some of these models. And even though, again, we don't have all the right answers, far from it, I think we should instill humility about what we really know and what we don't know. And I think we'll treat other human beings better. We'll be better as providers, we'll be better as public health leaders, and that's where I would like to end. Thank you.
Thank you. I think we have some time for some questions, and we're going to move some microphones to the front of the aisle so people can come and ask their question. Maybe what I'll do is while we're doing that, I will start with the first question. So, you know, our students in our first year foundational ethics class, I was looking around at all of you. The light should be going off, right? Because one of the things that we also think about in moral philosophy, in virtue ethics, is there's something very appealing about saying that we can cultivate ourselves to be the kinds of people that we want to be, right? As opposed to the kinds of people who are fallible and make mistakes, and are exquisitely environmentally sensitive. And I wonder, when we think about the kind of epistemic humility you've put forth in front of us, we do have this sense that we want to make the right choices. But in reality, while we're figuring out all the reasons how we can treat our brains and our neurons, should we be thinking more about the environments we create than the behaviors that we engage in?
Well, at least partly, right? I mean, if we take obesity as an example, there's this huge secular trend. And so our genes haven't changed that quickly. This is clearly environmental, but I think the experiment of physicians and other healthcare professionals telling people how to behave has not been all that effective. In fact, not at all effective. And we've even given people bad nutritional advice, right? Low fat, high sugar, although nobody remembers giving that advice, but it seems right now. And so I think insofar as we can, again, with due care, without the excessive stuff, because what we did in that bad nutritional advice was put SnackWells right in the front of everything and put bacon in the back, and that didn't make anyone thinner. So we really, again, humility, just ethically, it's just the most important stance we're early in the history of medical science, and which doesn't mean we can't give advice, right? But I think we should, we should ask, given what we do understand of brains and behavior and the things that influence them, what should we be advising? What should we be doing to environments? But always looking empirically and seeing what the effect is. Right, which we often forget to do.
Right, and then we'll go to Lachlan in a minute, but then there's also the same issue, right? Our very same folk psychology and explanatory models lead to the choice architecture that we engage in when we put the SnackWells in the front, right? Rather than putting the bacon in the store, right? So that it's all susceptible.
Yeah, it's all exactly.
Great. Okay, I'm supposed to remind you, I think this comes from Bob True. See, Bob, I do listen. A A question is relatively brief, it has a point, and your voice goes up at the end.
Steve, want to think about what you're saying about implicit bias and our ability to be aware of that. And then
Yes.
When Barbara sees your kids see you going down to the ice cream, or you see
Yeah.
yourself and then you don't always do it. Or
All right.
so maybe
Yeah.
the addictions.
Hypothetically, I don't always do it.
But all of us have experience of behaviors that we keep thinking we should try, we don't control. We also have experience that we have folk language for about, I have made a commitment to study harder or do this, and that changes our behavior. Can you try to describe in not folk psychology language what happens in the brain when we are not just
Yeah. No. I mean, there's just no question that people make decisions, and it changes their behavior. I don't think we actually understand why some people can do that and other people can't, and whether there is an active ingredient in those changes. But the one thing I will stipulate, it's not because the homunculus inside has looked in the mirror and decided to be healthy, right? So I think understanding at the neural and psychological level and the environmental level together, what can best motivate behavior change would be something worth pursuing. I already just touched on it a second ago. We have to respect human heterogeneity, right? So one of the things we do in these folk psychological models is we treat everyone in the same way. And we treat people who can't do that sometimes as failures, even pariahs. And I think we do have to also understand, just as we look for precision medicine, and behavior is much harder, right? There's just no question. I think we do have to look at human heterogeneity and figure out who can do what.
Hi, thanks for your talk.
Sure.
My question is kind of two parts. The first is, where on your research radar is semaglutide? Because I've heard that some people have found that when they're on it, certain things like people who are gamblers are less likely to gamble, or smokers are less likely to smoke. And with that in mind, do you foresee any risks around kind of criminalizing behaviors that are kind of seen as antisocial?
So the three interesting points. It's early, but I would like to believe that that's true, and that what you're seeing with these things, there are a lot of receptors around the brain, and I think one of the effects must be reward circuits. The second thing is, if you overdo it with reward circuits, people don't take their drugs. The classic example is antipsychotic drugs that block dopamine. And people who are on those drugs stop them typically in less than 6 months because life becomes worse. So it's worth keeping our eye on those things. And then the third thing is, I don't think that, I think a lot of the things that have less salience, if all of this turns out to be true, are already, in some cases, criminalized in some jurisdictions. But it's not criminalization that I worry about. It's really stigmatization, right? Which is you stop your drugs and and then people notice that you're actually gambling or something. Very, very complex social context around these things. Yeah. Thank you.
Steve, very stimulating talk. Early on, you gave a characterization of morality as a mechanism for ensuring group cohesion and the like. So, picture is
a little reductive, but
I'm just using it as a reference.
Yeah.
So, Homo sapiens have acquired a moral sense that induces them to do various things.
Yes.
And this has been very important.
Yes.
And you note that as a scientist, so that's sort of in the folk psychology realm. Now, you're the scientist looking at this, you understand that morality is a creation of...
Yeah, it's a construct of...
Right, okay. Now, so that's within the folk psychology realm. Now, you're the scientist interested in truth, you're standing outside of all that. Does that mean that you don't believe in morality?
No.
Wait a minute,
Yeah.
I don't mean that as an
Yeah.
insult.
No, but it's not that I don't believe in it. Let me make one antecedent point, which I haven't. We've done a terrible job naming brain functions. Yuri Busaki at NYU has said it's like we took the table of contents of a psychology textbook of the 19th century, and we have like phrenologists say, well, this is memory is, let's understand memory, let's understand fear, but we actually don't, and morality would be right in there, things we actually don't know what is encoded in the brain. That said, all of these things that we experience folk psychologically and name folk psychologically, again, it's not that I don't believe in them, they're critical for survival, they're critical for flourishing. It's just that morality is a little more ticklish, but they don't correspond necessarily to things that are to ontology, the way the brain actually works, the way the brain actually divides up the world. We have given a lot of approbation to appropriately so to morality in most instances, except when it goes over the top and becomes persecution. But that doesn't mean that there is that it corresponds to a circumscribed function in the brain, right? We just don't know we don't know is the point.
I'd love to argue with you.
Yeah.
Let's finish the next two questions.
Okay, we can argue. It's like the DSM. We know nothing and it is true, right? But anyway.
Professor Hyman, I'd like to ask about something about parenting.
Yeah.
Early intervention. So you talked about how people get in these rhythms. A pitcher, say, needs to return to their windup in order to throw a strike. When we talk about the most effective interventions, we're often talking late stage, right? We're talking about someone already addicted.
Mm-hmm.
We're talking about someone who already doesn't do their homework.
Yeah.
To what extent is the efficacy most dramatic when, say, a two-parent household or whatever else you'd like to believe is most effective makes your child learn these routines? And to what extent does that stop any future behavior beyond what you'd like to
I think well, I'm not an expert on this, but I think it's very important about prevention and screening. So ideally, you want to stop pathological processes before they get going. We know they can sort of make themselves at home in your behavioral habits or in your mind, in your brain. But these are really, again, these interpretations tend to be folk psychological. When we talk about, we can do an empirical study and look at single parent and two parent homes, but when we get down to the individual, there's a lot of heterogeneity. And my experience with prevention is that the well-meant attempts are a two-edged sword. So when I was NIMH director, there was a huge movement for screening people for depression and for suicide, suicidality. So the depression screening, very well meant, was problematic because there was not always treatment opportunities. So people would screen in, and then there would be no provision of treatment. But I think more telling about early intervention was the suicide screening. Suicide is all too common, rates are going up, but it is a small percentage of people who will screen in on any one of these instruments. And it is a small percentage of people who attempt suicide. And what happened with these screening tools is that young people were treated as ticking time bombs. and actually were treated very poorly in schools, by counselors, by families. Now, of course, this was well meant. It was an unintended consequence. But I think the truth is, before we intervene, we have really got to be far better at prediction. And this is going to have to include, for many conditions, genetics, biomarkers, societal context, social determinants, and we have to figure out whether we can have predictors, the benefits of which, or the utility of which, leads to preventive interventions that are better than leaving people alone. Sure. Yeah.
All right, we're going to go to Dr. Berry for the last question.
Thanks. That was great. I'm with the Bioethics Center, so it stuck in my mind the concept that we would prefer to mistake a stick for a snake than a snake for a stick. And admittedly, some of the errors that we make are ones that we can't choose, right? That are kind of given to us in a sense, an adaptive process. But on the other hand, there are some errors that we can choose to make in full awareness that we are making those errors. And so in consideration of the way in which science is still evolving with respect to our understanding of behavior, we're liable to make errors if we rely upon that science. Similarly, we're pretty sure that we're making errors if we're relying upon the folk psychological picture of a person. So I wondered if you could riff a little bit on the idea that if we're going to make an error, right, we have an expectation of doing so, are there certain domains within which we know we should be more inclined towards a particular form of error, whether it is the one that comes from relying on an evolving science versus the one that comes from working within a folk psychological model?
That's a great question. And of course, it's why I think, again, epistemic humility and follow-up testing of what you've done is really critical. You know, I don't, you know, I think as we, with these early sciences, as we intervene, we really do not know what we are going to get. Often we make dire predictions about certain outcomes that don't come true, and we miss real dangers. There are technological practices that, I'll just raise one, that worry me a lot. So now that we can, using first gene chips and now low-pass whole genome sequencing, derive polygenic scores for both illness phenotypes, but also even strange things like educational attainment, right? Which is some mixture of cognitive ability and conscientiousness and things that made your parents rich, and you know, what's happening now is that there are companies that are trying to partner with IVF clinics, and they say, well, we take one cell now to test genetically to make sure we haven't introduced a chromosomal anomaly, or maybe you're a family who's having IVF because you want to make sure there's no Huntington's gene being passed on. But while we have this DNA, we have enough to do some polygenic scores, and if you're concerned about the risk of type 2 diabetes, you know, we could test for that. But why not, why not test for cognitive ability or educational attainment? Because of criticism of these things have disappeared from the menus, but I'm sure you can still order them. One of the most chilling to me was there was a European company offering to predict skin tone. So, you know, so why do I think this is an error? What they would say is, look, parents, we're not going to change the human gene pool vastly in these few IVF clinics, and parents have a right to blah, 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 you know, they want their kids to flourish. And I am worried about what I call liberal eugenics, non-coercive eugenics, and about ways of further stigmatizing already devalued phenotypes that go culturally well beyond that individual. And I worry about being Pygmalion in your family, and when your kid is unhappy and they find out that you tried to pick their genotype, you picked which embryo, and the others were frozen or thrown out, what that will mean. But I don't know, right? And the people who have started these companies, you know, including people I know at Stanford, very entrepreneurial, they say, no, that I'm making, I am like a folk psychologist. I'm just making these predictions about my nightmares, and we have to see empirically. But I think that the real issue then for things like this is again, somebody's got to watch what's happening, and we don't. We fail. So as cannabis gets legalized, it's now, because of plant breeding, it's very high potency. And we have not organized ourselves to understand what happens. Well, you know, cannabis simulates powerful inhibitory neurotransmitters in the brain, and during adolescence, while your brain is developing, that could lead to weaker synapses and synapse loss. And there are some early observational studies saying there's more schizophrenia that there wouldn't have been. But in states that are legalizing these drugs or psilocybin, I'm not against it, but I think we have to understand what we're doing, because it may turn out to be a terrible mistake. So that's my answer, right? I can't generalize ahead of time, but I think this kind of thoughtful observation, openness with data and reporting is the only way to go about these things.
Well, I think based on that lecture, we can be certain that the second century of gay lectures will be even more provocative than the first. And thank you. Please join me in thanking